Today I will be talking on the topic called fuel injection systems for a gasoline engine. So the content of the topic fuel injection system for a gasoline engines. It includes as per the course manual or a course handout. So these are all the topics which are there, which includes single point and multi point fuel injection systems and direct injection systems. Feedback system, basically the feedback from the electronic control unit with respect to the engine speed, how much should be the quantity of fuel injection should be there, and how the flow is happening, the intake manifold, what are the descent requirement, what are the airflow requirement, how the flow pattern comes. The flow pattern here indicates air and fuel. First air comes separately, fuel comes separately, both air and fuel gets mixed, and you get a flow combination of both air and flow, air and fuel. So you will understand all these things. And we have seen lean mixture, rich mixture. Lean mixture is the one where we have less fuel and more air. And rich mixture is the one where you have more fuel and less air. And we will be seeing the gasoline direct injection system. Basically, we will see the BOS GTA system. And these are the topics that we have seen last week. How the fluid motion, basically the air fuel mixture in the combustion chamber, how it will vary with respect to the turbulence characteristics, still motion, traverse valve, and then how it will avoid the global gas, how it will interact such a way that piston will generate the heat and distribute the heat without affecting the system. So we have seen the fluid flow in the last class. So this class we will concentrate only on the injection system. Okay. Leaving apart the syllabus what we have in the course manual, I will be stressing more towards the fuel injection system, which covers basics and also the types of fuel injection system what we have for a gasoline system. And then I will stress upon gasoline direct injection. What is the comparison? I'm going to give the comparison between the GDA engine, gasoline direct injection engine, and also the multi-point fuel injection engine. What are the difference and what are the advantages of the GDA over MPFI? And then we will see some of the characteristics difference between GDA and MPFI, and we will also see is the output comparison with respect to the performance, vehicle acceleration between the GDA and also MPFI. These are the things we will be covering in today's test seminar. Okay. The petrol injection system, okay, it basically called a gasoline. It's also called as a SA injection system. So we have different types of petrol injection system. Petrol injection system is divided into two categories. One is indirect injection, and another one is a gasoline direct injection. I told you we'll be comparing the gasoline direct injection with multi-point fuel injection system. And again, this multi-point fuel injection system is coming under a type called indirect injection, where it's basically the injection will happen in the manifold. So it's also called as manifold injection. And again, this indirect injection is again divided into two types. One is a single point injection system, and one is multi-point fuel injection system. And again, when I say multi-point fuel, it is again a throttle injection and also port injection. When I say single point, it is throttle injection. Again, it is also a port injection. So either a single point fuel injection or a multi-point fuel injection will have a throttle body injection or a port injection. So these are the overall types that we have for the petrol engines, basically the injection system. So these are all the four players. They play a vital role with respect to the injectors injection system in India and also in abroad. The boss company, they manufacture, they develop the injectors. Then so a European-based company, Siemens and Delphi. So all these companies, they are the players with respect to the injectors. These are all the standard gasoline injectors that companies they manufacture. So in the earlier days, before 1980s, we use carburetor. We don't use injection system. What we have seen, but now we are going for the injection system. Yearly 2000, year 2000, every OEMs they are going with a multi-point fuel injection system over carburetor, and even up to 2010 and 2015, many companies they still follow the MPFI. But now people are going, I mean, hard OEMs are going with gasoline direct injection system. It's also called as a direct injection system. Uh, Morphology has taken place from carburetor to port injection, basically multi-point injection. And then from there again, they are going to the gasoline direct injection. We will see what are the difference between the carburetor, multi-point fuel injection, GDI, we will see it. Um, Basically, in the case of gasoline direct injection, the injectors inject the fuel. The fuel is sprayed into the combustion chamber directly. Whereas in the case of the multi-point fuel injection, uh, unlike the gasoline direct injection, it is not directly sprayed into the combustion chamber. In the case of carburetor, there is a venturimeter is there, uh, which will increase the, the area and then the diameter, and accordingly you use the fuel supply system in the carburetor. We will see how the function of carburetor, multi-point, and GDI is going to happen. And nowadays, we are also going with advanced system called vaporized fuel injection system, gasoline. That is one of the recent advancement which is happening. This is beyond the gasoline direct injection. With respect to the system, apart from carburetor, we have the injection system. It includes three types. One is the single point injection system. It's basically indirect single point injection system where uh, you place the injector, the center, uh, and here air and fuel gets mixed and it goes to the combustion chamber. In the next method is indirect multi-point fuel injection system, where you inject the fuel in multiple points. Say for example, each cylinder will have one injector. So if it is four injector, if it is four cylinder engine or three cylinder engine, you might have a four injector or three injectors correspondingly. Whereas in the case of single point injection system, you have only one injector irrespective of number of cylinders you have. So you're not going with single point unless you have a single cylinder engine, because the efficiency point of view, the flow pattern not much efficient in the case of single point fuel injection system. And the uniform distribution of flow will happen in a multi-point fuel injection because you usually distribute injection across all the cylinders equally. And the third important type is the direct injection system, basically the gasoline direct injection system. It can be a gasoline direct injection, it can be either a single injection or it can be a multi-point injection. It can be a single injection for a single cylinder engine, and it can be a multi-point injection for a multiple cylinder engine. Strictly speaking, even it is a multi-cylinder engine, then we apply a gas indirect engine, considering the multi-point injection system, where the injector will inject fuel into the combustion chamber directly, and you get the advantage of the emissions, power output, the acceleration. You get a lot of performance improvement. Basically, the emission point of view, you get better, I think. And we will see the comparison between the multi-point fuel injection and EDI on case study. And again, the position of the injector is also very much important. While we're designing the position is also very much important. Okay, so this is the B category. What I have shown in the previous slide, it gives better understanding in this slide now. In the case of a single point fuel injection system, you have the single injector, which is placed. This is the throttle valve where it will allow the quantity of air to the system. You are placing the placing the injector near to the throttle valve. So as I said, the gasoline engine is the one where you get air and fuel mixture during the intake stroke and during the during the section. Okay, the air and fuel comes into the intake manifold and it goes to the combustion chamber. Whereas in the case of diesel engine, only air comes. And you see here, in the case of a single point injection system, you are going to have a single injector placed near to the throttle valve, and you are going to have whatever you're going to get, the fuel and the air, which whatever is going to get mixed, it is getting distributed to the cylinders. Here it is a four-cylinder engine. The problem with the single point injector is you cannot get the sufficient amount of quantity of fuel because you need to have the pressure system such a way the air and fuel is going to get distributed equally across all the four cylinders. It is highly impossible because the quantity going here may be higher than here or here. It may not be even. So in order to have the even distribution of injector into the combustion chamber and to the system, we are going with the multi-point injection system, where you have the multiple injection, which means one injector for one cylinder. Because here you can get better combustion, you get a better air fuel mixture, and you can get higher thermal efficiency, volumetric efficiency, combustion efficiency, um, and even the emission can be controlled, and even the quantity of fuel, whatever needs to be injected, also can be controlled with the help of electronic control unit. Suppose and again, the quantity of fuel getting injected into the system will also vary with respect to the engine speed. The last important type is gas direct injection, where the injection will happen directly into the combustion chamber, where you get advantages of emission and power output. So the graph will get increased when you're going from the carburetor to single point, and the single point to multi-point, and the multi-point to direct injection, and direct injection to the last advanced improvement. What we have is vaporized fuel injection system. So the performance is getting increased from carburetor to the vaporized injection system, and we have a lot of advantages when you move from carburetor towards the different injection system. See, this is the injector which is used in the multi-port fuel injection system. This injector, and you see here, this is the valve. Okay, this is intake valve, and I told you four stroke. You have four stroke which will complete one cycle. During the intake stroke, air fuel mixture comes when the piston moves from TDC to VDC. When the piston moves from TDC to VDC, the inlet valve opens. Okay, this is the inlet valve, it opens. When the inlet valve opens, the air and fuel mixture comes into the system when the piston moves from TDC to VDC, and then the next stroke is the compression stroke where the piston moves from VDC to TDC, and you get the compressed. Okay, this air and fuel mixture, whatever you're going to allow in during the test stroke, get compressed. And we follow the other two stroke called the power stroke and exhaust stroke. And this is the injector that is being used in the multi-port fuel system. And I told you you have the single point fuel injection system where you're going to place the injector near the throttle body. This is the throttle valve basically. Throttle valve is the one will allow the required quantity of air into the system for the combustion to take place. Because you need to have air, okay, which contains oxygen, for which will react with the fuel and it creates it forms a combustion. So this single point injection system is also called as throttle body injection system. Um, this is the throttle body, and you are going to have the similar thing, like you are going to have the injector, single injector you are going to have. You also have the throttle position sensor, which will sense uh, based on the engine speed and based on the requirement. It will open the throttle valve basically. And you also have the air control valve into the system. And basically, the throttle valve it will allow the required quantity of air into the system corresponding to the vehicle speed or the engine speed. Higher the engine speed, you need to have higher fuel, for which you need to have higher air, and accordingly the valve percentage of throttle valve getting opened will vary. And when the engine is running or when the vehicle is running at a low idle RPM, where the speed is very much less, where you get less quantity of fuel getting injected into the system, for which you can have less air. Accordingly, you can supply the air into the system through throttle valve. So the throttle valve getting open in terms of percentage gets less when the vehicle is running in low idle RPM or in city traffic condition. So when the vehicle is running in highway or expressway, national highway, so the percentage of throttle valve getting open is going to be higher. And accordingly, you also have the system based on the electronic control unit, you get the feedback, and accordingly, the quantity needs to be injected. This is the system comprising of the fuel injection. Like you have the fuel system. Basically, you have the fuel tank, fuel pump, and then fuel filter. And you see, you're going to have the electric fuel pump, and you're going to have the accumulator and the fuel filter, which will filter uh, the fuel. And the accumulator will accumulate the fuel from the tank into the system with maintaining the pressure, and it will also relieve the required amount into the filter, which will enter into the system for injection. And you have a fuel distributor which will distribute. Suppose if you have 4 cylinder, it will distribute equally to 4 cylinders. Okay, and this is the fuel system, and you have the air system. Similarly, the medium is air instead of fuel, and you have the filter. Even you need to clean the air, like how you are going to clean the fuel. So air cleaner, you have airflow sensor. Basically, we have seen in the last slide the sensor, throttle push sensor you have, and again accordingly you also have the airflow sensor, and you also have the throttle valve which will open and it will close depending upon the requirement, and it gets inducted into the intake manifold. And you see here the air and fuel mixture. So the air the fuel comes here and the air comes this way. So both and the air and fuel gets mixed and it goes to the combustion chamber. Uh, and this is the intake valve. Basically, you have this is the intake valve. When the intake valve opens, what happens is both air and fuel mixture comes into the system during the intake scope. I told you in the case of gasoline engine, both air and fuel gets mixed, and it comes as a combination during the intake stroke. Whereas in the case of diesel engine, it's only air. The anatomy of electronic fuel injection system. Uh, Basically, the EFI we call electronic fuel injection. Okay. It comprises of different parts. It is having the fuel inlet, is the location where the fuel gets in, and it is having the electrical connection. It is a solenoid operated fuel injection. It is the body of injector. It is having the head and seat. Basically, it's pintle type, and it's also having the return spring. Basically, the based on the required amount, the fuel gets pumped from the fuel system, from the fuel tank into the injector. You also have the pump, filter, and then when it comes there, it goes to the injector. Based on the force, the spring gets actuated, and it pushes the fuel from the inlet into the injection system, where it will inject the fuel with respect to the engine feedback coming from the ECU. Depending upon the engine RPM, the quantity of fuel gets varied. So higher the RPM, the quantity higher, and accordingly the spring instead. Actually, we had a carburetor system. So the morphology has taken from carburetor to single point, multi-point, GTA, and vaporized fuel system. And we will see what is the old carburetor system, how it looks. So we'll see just a basics alone. So this is the carburetor cross section. So this is how the air comes, and you have the fuel. You have the venturi meter. This is the venturi meter, and you have the throttle valve. As the function of the throttle valve is it will allow the required quantity of air, and this is the fuel coming in the one direction and the air coming in the other direction. Okay, and before it goes to the inlet valve, both air and fuel gets mixed. Okay, so now this carburetor works on the principle called carburation. Here, the air and fuel gets mixed and you get a combustion by proper amount of the fuel getting mixed with air before you are going to admit to the cylinder, basically the combustion chamber, and you call this process as carburation, and the device which does this job is called as carburetor. And the factors here which is affecting the carburation is the engine speed, because you don't have the proper control, unlike how you have for a MVFA or GTA. And again, the vaporization characteristics of the fuel, uh, and the temperature of incoming air. So you cannot avoid, or you cannot have the control over the temperature. Again, the design of the carburetor is also one of the key input that initially was not been done in a proper manner. And again, fuel it's been atomized in such a way by relying on air speed. Suppose if the speed of the air or the velocity of the air is going to be lesser, then accordingly the carburation efficiency may be lesser. So there are a lot of drawbacks that this carburetor had initially. That is a reason the performance of the engine is also less, and that paved a way for the multi-point fuel injection system. And the preparation of the charge is done outside the engine cylinder. Okay, so here the charge here indicates the air and fuel mixture is done outside the engine cylinder. Engine cylinder here is basically the combustion chamber, and this is appropriate for a four-stroke and two-stroke engine, especially for light-duty vehicles, because petrol is more volatile as compared to diesel. I will see why we are going for a fuel injection system over carburetor. Uh, in the case of carburetor, you have choke, okay, because you need to every time, even some of the vehicles even have now a choke system, the older vehicle. So whereas in the case of fuel injection system, it has no choke, okay. So but here, because of fuel injection, what you have is you have the spray atomized fuel directly to the engine. So you need to have the choke here in order to have the proper atomization before it is going to the engine cylinder. Whereas in the case of the fuel injection system, the sprays are being atomized in a proper manner before it is directly going to the combustion chamber. And again, EFI, shortly called as electronic fuel injection, is shortly called as EFI. It also integrates more easily with the ECU, the engine control system, uh, whereas this is not there in the case of a carburetor. Again, you have a multi-port fuel injection, which will deliver a more evenly distributed mixture of air and fuel to each of the engine cylinder. So I told you, you can get a distributed amount of air and fuel equally, whereas this is not possible in the case of carburetor. And again, even this is not possible in the case of single point also. Uh, even that is possible only in the case of the multi-point or multi-port fuel injection system. And again, the fuel injection is sequential. It improves the power and it reduces emission, which is not happening in the case of carburetor. So that is the reason why we are going from carburetor towards the fuel injection system. So we have different components which are involved in the electronic fuel injection system, which involves three important parts. One is ECU, shortly called engine control unit, is shortly called the CCU. You have the sensors, you have the fuel injectors. ECU is, basically it's a computer that controls all of the electronic components on the engine. So I told you the quantity of fuel getting injected from the fuel injectors is based on the speed of the vehicle or speed of the engine basically. So ECU gives a signal. According to that, the fuel gets injected into the system. And you have sensors. Uh, we have seen sensors like oxygen sensor and basically in the case of a throttle valve, how much quantity of even we have the intake throttle position sensor as well, where it will sense depending upon the quantity of air which is going to get entered into the system, the, the percentage of throttle valve gets open accordingly. And this the loop what you're going to get, the feedback loop is going to be a closed one, where you're going to get the signal or the input from the ECU to the engine, and the engine gives the input to the oxygen sensor, and basically you get a closed loop again. Again, from the oxygen sensor it goes to the ECU, and the important thing what you need to look here is uh, the fuel injection quantity and at what time the fuel needs to be injected. So we have seen the port timing, valve timing diagram for a two-stroke engine, four-stroke engine, for SA engine, and also for a diesel engine. So in the case of SA engine, so we have seen how the valve timing performs. Okay, say for example, at what point of time the fuel gets ignited into the system. So this is very much important because lower or higher the, the injection or ignition. So it will also affect the valve overlap period, and again that will also have the corresponding problem with respect to the engine power output and also the torque output of the engine. So the power is directly proportional to torque, and power can be defined as 2 pi mt by 60,000. So, and with respect to the different speed, you get different power and different torque. So you need to have the required amount of torque and power which can be maintained by proper combustion, and a proper combustion can happen only if you have proper air and fuel gets mixed into the combustion chamber. That is possible if we have the proper signal through the computerly managed electronic control unit, engine control unit, you will call. So there are different types of sensor. We will see that in detail, and I told you this is very much important. The correct amount of fuel needs to be injected for every operating condition, because the engine is not going to operate in one particular condition alone. Okay, and because you have a lot of different operating conditions. Okay, when the vehicle is running in normal road and when the vehicle is running in higher altitude, lower altitude, and different climatic condition, you have different operating condition. Basically, it's not going to get operated in one particular uh, condition alone. Even when the vehicle is running in city traffic, city condition, and when the vehicle is running in highway, the operating condition will vary, the temperature will vary, and accordingly, you need to. And again, the speed of the vehicle also comes into picture. The speed of the engine also comes into picture. So accordingly, you need to inject the fuel. So lower the speed, if you inject more fuel, then it goes to the unburned fuel. So you get a higher hydrocarbon output. So you get emission, higher emission if you inject more fuel, because you are going to inject fuel unnecessarily, which will not get burned. Uh, say for example, if you inject more fuel than the required, and if you get, because throttle valve is the one you have the sensor depending upon the speed of the engine, you are going to allow the required amount of air into the system. So if you allow less air, whereas you are injecting more fuel, then obviously some of the fuel is left unburned. Okay, it will not get burned. Okay, you will not get a proper combustion. And when it is left unburned, you get unburned hydrocarbon. So hydrocarbon is one of the emission. Okay, and again you get when you have the hydrocarbon, even the carbon monoxide is also present in the particular fuel, because um, CHO is there in the chemical structure itself. Okay, that will lead to uh, the carbon monoxide as well. And again, so carbon monoxide and hydrocarbon will have higher emission. Then again, it will affect the emission as well. And even it will go to the rich mode sometimes. Even see, the rich mode is also good. See, when the vehicle is running in higher RPM, you get higher injection with respect to the fuel. Rich mode is also good, but when you're having the rich mode without with less combustion efficiency is a problem. The rich mode with higher combustion efficiency is better, but if the rich mode is lesser combustion efficiency is a problem. So I will tell you how the rich mode is going to happen with higher combustion efficiency, how rich mode is going to happen with lower combustion efficiency. So for example, I told you when the vehicle is running at higher RPM, you will get high amount of fuel getting injected into the system, and the air again obviously will come into the picture. Obviously, you get combustion, but you see, when I say the system like this, where you inject more fuel, but less air, which is leading to the incomplete combustion. Okay, in that case, you get less combustion efficiency. So obviously, we have seen a lot of things like lean mode, rich mode, and psychometric mixer in case of even catalytic converter. We have seen a lot of things how the efficiency varies, and we have seen this is applicable not only for petrol, even this is also applicable for a diesel. This three type of mixer, and we need to ensure that even if the vehicle is running in rich mode or engine is running in rich mode, even in that case, we need to ensure that You need to give more focus towards the combustion point of view. Okay? Higher the combustion efficiency, you get the power output higher, you get higher efficiency, volumetric efficiency will also be higher. And of course, the volumetric efficiency is no matter related to this, but now we are going to concentrate towards the combustion point of view. And when the combustion efficiency is higher, you are also going to get higher the mechanical efficiency. Okay, so we see the sensors with the sensors. So we have a lot of sensors which will give the signal of, to the system. So you have the airflow sensor, guessing, and you have a water temperature sensor which will sense what is the coolant temperature, and you have the oxygen sensor even here, and you have the sensor which will give the signal based on the engine speed from the electronic control unit, and accordingly even the speed you are going to give the acceleration, which is the input. Okay, you are going to press the pedal, accelerator pedal, to increase the speed of your vehicle. So when the accelerator pedal is pressed, okay, you are going to give the signal. You're going to give an intimation to the electronic control unit that you are going to increase the speed of the vehicle. And when you give the signal that you're going to increase the vehicle speed or the engine speed, then this control unit will give a signal to the injection system. Accordingly, injections going to get injected. It can be either a direct injection or direct injection or the multi-point fuel injection system. Irrespective of that, this system will give the signal. Accordingly, the quantity of fuel getting injected will vary. See, this system is very much important for both multi-point and also for a gasoline direct injection. So it is not that this system we have the ECU or the quantity which needs to be controlled only for a gasoline direct, not for MPFA. So the system is there for both things. And with respect to the system, what you have nowadays, even you have the EGR valve even for a gasoline engine also, and accordingly the exhaust gas gets recirculated to the intake manifold. And again, when the exhaust gas is getting recirculated to the intake manifold, what happens? It mixes with the air. The temperature of the air is going to get increased. Okay, and the premixer will also happen. The air along with the fuel, the temperature again is going to get slightly higher, and that is going to get injected into the system. So this is the complete loop that you are going to get. Basically, it is a closed loop. You have the pressure pump. Basically, the fuel from the tank gets pumped into the fuel injection system through this electrical pump. You have the filter which will clean the fuel. So this is the again we are going to see in depth. So I have told you this. You have a single injector for a single point injection system which is placed near to the throttle valve. So here the fuel entrance. The indicate the number one indicates the fuel entrance. The fuel gets entered here and it gets injected. And the number two is the air entry. And the three is the throttle plate or the throttle valve. Okay, where it will allow the quantity of the mixer. And the four is the admission. Admission in the sense it admits the air fuel mixer to go to the system. And five is basically it is injector. So this is the injector. So you have only one injector, whereas in the case of multi-point fuel injector, you have individual injector. And six is basically the combustion chamber engine basically. Okay. This is the cut section of a single point fuel injection system. So basically, three type of analysis is required here. One is how the fuel is getting entry into the system, how the air is going to get entry into the system, how the fuel and the air is going to get mixed and is going to the combustion chamber. Is what very much important that we need to look into it. We will see the air coming from the atmosphere comes in this direction, and you have the throttle valve which will allow the required amount of air which is going to the system, and you have the fuel tank uh, where the fuel gets pumped from there to the is the getting fuel going to get in enter and it goes to the injector, and this is the mixer where the air and fuel gets mixed here, and you have the throttle plate where it will allow the required quantity into the system into the combustion chamber. If it is a single cylinder, you have one injector, but in the case of the single point, is basically only one single injector you have. So now the same principle is applicable for a multi-point fuel injection system also. Only the difference here is you have a separate injector, fuel injector for each cylinder. And why you need to have a separate injector is that it will have better distribute. For the better distribution, need to have the individual injector, and it will also eliminate the need to preheat the intake manifold. You no need to preheat the air which is coming into the intake manifold. This is the system. You see, it is the air getting entered. You have the air filter, and this is the fuel getting injected, and and before see this is the intake valve. When the intake valve opens, this is the air and fuel gets mixed and it goes to the when the piston moves from TDC to BDC, it goes to the combustion chamber. This is how multi-point fuel injection system works. So this is the intake manifold. So here the advantage is that it eliminates no need you no need to preheat the mixture in the case of the intake manifold. So you have the in the case of multi-point fuel injection system, you have the fuel tank, and it will from the tank it the fuel pump will pump the fuel from the tank, and it takes to the fuel filter, is the line, and it goes to the injector. Basically, it is a you call this as a pressure line. Basically, the high pressure, and it gets injected. Basically, it is 15,000 psi or 1,000 bar. You call. It will also vary with respect to the different engine configuration as well. And you have the pressure regulator. It will control it will regulate the pressure. And you have a return line. And excess quantity of fuel, it gets returned here, and it goes to the fuel tank. This is the gasoline direct injection line diagram. So you have almost all the components same between MPFA and gasoline direct injection. But only difference is that you're going to position the injector such a way that will get injected into the combustion chamber directly. Okay, this is only one difference. Whereas in the case of multi-point fuel injection, you're going to have the injection uh, which will happen before the inlet valve. Okay, but you see here, the case of GDI, you are going to directly pick the combustion chamber. We will see what are the advantage of this GDI. And you have the fuel tank, and you have the fuel pump, and it what we have seen here. And you have the high pressure fuel pump, which will pump the fuel from the tank to the system. And you have the fuel line, basically the high pressure fuel line I told you. And even you have the fuel return valve or fuel return line. Okay, based on the pressure regulator, it again it comes to the tank, and it is completely operated with the help of ECU based on the signal, based on the inputs what is going to get. Okay, now I'm going to compare for the engine having the bore of 81 mm and stroke of 89 mm, and the displacement is basically pi by 4 d square L. Okay, when you multiply this pi by 4 diameter square into the stroke length, you get 34 cc. Two intake valve, means two intake valve and two exhaust valve per cylinder, and the compression ratio. You see here, I'm going to compare with this configuration. I'm going to compare between GDA and the multi-point fuel injection. Here, when I use the GDA system, my compression ratio is going to be 12 RS. When I use multi-point, it's going to be only 10.5. See, higher the compression ratio, I told you in the beginning, when the compression ratio of the engine is higher, the thermal efficiency of the engine is going to be higher. The thermal efficiency is going to be higher. I also said the brake specific fuel consumption of the engine or the mileage of the vehicle is going to be higher when the compression ratio is higher. Okay. Uh, and that's the reason I also compared the compression ratio between a diesel engine and also the gasoline engine. The diesel engine having the higher compression ratio, higher thermal efficiency, will have a higher mileage, lesser BSFC, and the gasoline engine having lesser compression ratio will have lesser thermal efficiency and less mileage and more fuel consumption and more BSFC. So that is the reason I have compared. So there is a possibility that you can increase the compression ratio higher than what we can have for a multi-point fuel injection system. But at the same time, there is some limitation in the case of gasoline engine, where you cannot increase the compression ratio beyond 11.5 or then between 10.5 to 11.5 is okay. But still, if you want to increase you get a problem of knocking. Okay, because you get higher, you get the pressure overshooted in a lesser time. It will result in a knocking sound, and even that problem can be overtaken by the proper mixer of air and fuel mixer. And this comparison gives an overview where you're not going to get knocking issue or the abnormal combustion or the abnormal pressure is going to get put up when you're injecting the fuel into the system along with the air. And again, you see the compression chamber, when you're going for a GDH kind of thing, the piston top portion should be curved. Okay, so that when you have the curved portion, the fuel injection directly getting into the system gets properly burned, and the performance will also be much more better. So when you're going for a conventional, you can have the piston with a flat top end, means it can be flat. You need to have the curve, and when the system when you're going for the GDI, the intake port should be upright straight, whereas it can be standard like as a MPFI. And the fuel supply system is in cylinder injected into the cylinder. So here you're going to have the port injection. Okay. So the pressure again, here you're going to get higher pressure. The pressure at which it injects will be higher, whereas the pressure where the fuel pressure is lesser in the case of multi-point fuel injection system, because you have the injector for the individual cylinder, uh, but you have only system like where you need to increase the pressure when you're going for a direct injection. So this is the technical features of a GDA engine having upright straight intake port, and this is the curved portion of a piston. The piston will be like this, okay, and even the high pressure fuel pump is there. And again, you are also going to have the high pressure spill injector. You see here, this is the upright straight intake port, and this is the high pressure spill injector. It will cause spill motion, and this is the swirling pattern we have sprayed. Even reverse swill is also, last class we have seen the swill and swill motion, and even the turbulence, tumble motion. We have seen a different type of fluid motion. Sometimes the reverse swill is having two effect. It can give a good effect, or it can also give a bad effect. So when I say it's a good effect, what is that? The reverse swill means uh, the you see the reverse swill or even the reverse tumble. You can use it will give both good effect and also bad effect. So when I say it's a good effect, so you see the red one, it is going to the tumble flow, the air and fuel mixture, going to come here, and again it's going to get the reverse one, and again it is going to come into the system. So when I say it's a reverse flow, uh, if uh, if this flow is having the proper air and fuel mixture, and the combustion is going to be good, and if it is in a completely vaporized form, then it will not affect the incoming air and fuel into the system. Suppose if this flow is having more fuel than air, and this will when it is again creating when it is again it is mixing with the incoming system, then there is a possibility it may reduce the combustion efficiency of the incoming system where the air and fuel gets mixed already. So there is a possibility of both effect, but normally we need to look into the system where you are going to get the reverse flow. Uh, Basically, the swivel motion is also good. The reverse swivel is also good, but the pressure which the swivel is going to get or the tumble flow is going to get, it should be higher. So in such case, the reverse flow can happen with higher pressure. If the pressure is higher, so I told you the bad effect also. So what is the good effect? So if you have higher pressure, irrespective of the mode of mixture like rich or lean, so if it is a rich mixture where you have higher amount of fuel than the air, even if you have the rich mode with the help of the tumble flow or a spill flow, what happens is, since you are going to create a reverse flow with high pressure or high velocity, you have lesser time for the reaction to take place from the air and fuel to the system. So what happens is, uh, when the pressure is going to be higher, velocity is going to be higher, then you have less reaction time. So you can avoid uh, the lesser velocity or less pressure, so that it will not have the bad impact into the system. So I also told you you need to go for a the curved top piston. Going for a GDA. You have the high pressure fuel injector. So here that is the reason you're going for a high pressure. And the injector should be, when you're injecting with the high pressure, what happens is, even the swirl motion or the flow will be with higher velocity or higher pressure. So this is how the pattern comes, the fuel pattern. The major characteristic of GDI engine indicates you are going to get a lower fuel consumption and higher output. This is the main advantage that you have when compared to that of multi-point fuel injection. So when you have vaporized fuel injection, this is the advanced one, which I'm not going to cover, but just I'm telling that we also have the vaporized fuel injection system. Still, that is having much more advantage than GDI. And when you're going for a GDI, what happens is you get the ultra lean combustion mode. Ultra lean in the sense the proper amount of air fuel, so because you're completely going to burn the fuel with a high amount of air, and you're going to have the superior output mode. And you are going to get the operation in two mode. One is the partial load operation and a high load operation. So we will see how the GDI is going to perform in partial load condition and high load condition. In the case of partial load condition, uh, here what happens is you're going to have the compression stroke injection. You're going to have the stratified air fuel mixer. So when I say it's a stratified, uh, it's basically the correct amount of air and fuel mixer to increase the output of the engine. And you are also going to have the ultra lean combustion where you have more amount of air into the system for the fuel to get completely burned, and this will result in a lower fuel consumption. And it is irrespective of that. We don't need to compare between the diesel and petrol at this point of time, but I'm going to compare the GDI with MPF. Okay, I'm going to because if I'm comparing it now, it may confuse you. And tomorrow, when I take the fuel injection system for a diesel engine, then I will compare, put together between the fuel injection system comparison between diesel and the gasoline. So when I say the fuel consumption, it is lesser. The overall fuel consumption will be lesser for a diesel. That I will tell you tomorrow. But looking at this system, I am going to compare between multi-point fuel injection and GDI. And in the case of the high load condition, you are going to get intake stroke injection. And here the mixture is going to be homogeneous where air and fuel gets mixed. You're going to get a stoichiometric combustion in high load, because in high load even the speed will be also an higher speed where you inject more fuel. According to that high load, you need to have the high amount of air into the system, for which the GDA will be helping. So you are going to have the stoichiometric combustion in the sense where the combustion will be much more better, and you are not going to leave any fuel which is going to be unburned, which will lead to the emission point of view. And that is the reason you are going to get more power also when compared to that of a conventional petrol engine. This is the different configuration between the GDA and the conventional multi-point fuel injection system. So you have the cylinder airflow where you are going to inject the fuel directly into the system. In the case of in the case of GDI, whereas in the case of MPFA, you are going to have the fuel injection from the port. And I told you reverse tumble and the reverse filling is going to happen with high velocity and high pressure. So you will have a good effect, not on the bad effect. And this is how the swelling flow happens. You see the velocity, okay? Velocity is too high. Okay, even you can see, you can imagine. You see how the fuel pattern comes. Okay, when it is injected into the combustion chamber or into the system where air and fuel gets mixed. This is basically the different view of how the fuel gets spread. And in the case of a stratified charge, it looks like this. In the case of homogeneously, I think the spray comes, even the angle is also very important. Okay. I also told you, depending upon the speed, the quantity, the pressure, even the injection pressure also gets varied. So the GDA having 50 MPa, and whereas of MPFA is only 3.3. The higher the pressure, even the angle, cone angle will also get varied. the shape will take a different shape basically. And with respect to the piston point of view, the piston looks like this in the case of when you're going for a GDA kind of thing, whereas the piston remains flat when you're going for a multi-point injection. So we will see the comparison between the multi-point and then the GDA with respect to the crank angle and then heat release rate and cylinder pressure. The cylinder pressure is going to be higher for a GDA engine when compared to that of a conventional multi-point injection. And even the heat release rate is also going to be higher. And you're going to get higher peak. Okay, that means the pressure gets higher, means you get higher power output also. But it is not that you are going to get abnormal pressure or the abnormal combustion. The combustion is going to be proper at the same time. When the combustion is going to take place, the pressure gets suited up. The pressure is going to get suited up, which means it's not abnormal pressure. Here you're going to get the proper amount of proper output with respect to power and also power. So we have seen the stages of a combustion in the case of SA engine, where you have the ignition. Once the ignition starts, you get the combustion. So when doing the combustion, the pressures get suited up. When you're retarding the ignition or over advancing it, when you're over advancing it, you get abnormal combustion. When you're going for a retarding one, you get reduced power, torque, etc. So you're going for a normal combustion. Even when you're going for a normal combustion, your pressure gets suited up, and you will not get a knocking sound. Okay, so even if the compression ratio is going to be slightly higher, when the compression ratio is going to be higher, even the cylinder pressure is also going to be higher. Accordingly, the heat release rate is also going to be higher, and your fuel consumption is going to be lesser. I told you in the previous thing also. So when the fuel consumption is going to be lesser, you get higher mileage. It is all correlated with respect to different parameters. We will see the behavior of a fuel spray basically in a compression stroke. This is the one of the methods that is being taken. So here, based on this pattern, they have derived the tank angle versus pressure or heat release graph. This is the graph basically. So here, the condition what they have done is they have taken the fuel spray 40 degree before top dead center and 30 degree before top dead center, 20 degree before top dead center. So based on the variation with respect to the fuel injection, so you also going to get different spray pattern. And finally, what they've done is they've selected the pattern which will be much more efficient with respect to the combustion point of view. So they out of these three systems, they've taken one particular pattern, and that particular pattern is being mapped to the graph between crank angle and the pressure and heat release rate. And it is one of the research paper where they have done the comparison for one of the engine, and the particular corresponding to the particular degree they have mapped this one. Okay. So here this graph is giving you the idea that it is having the much more better combustion efficiency with respect to the comparison when you are comparing it to multi-point fuel injection system. And this is the comparison with respect to the multi-point fuel and GDA during the idling condition and also during the cruising condition. Now, when the vehicle is running in idle condition, you get the lower fuel consumption, which means you get higher mileage. And this is the conventional multi-point fuel injection system. And almost with respect to the base, almost 40% reduction is there with respect to different speed of the engine, and you get the fuel consumption as well. This is one of the example taken in a manual transmission vehicle. And with respect to the cruising condition, and I guess running with different air fuel mixture, and different you get a different fuel consumption and different torque fluctuation also there. So in the case of normal multi-plane fuel injection, you get a lot of torque fluctuation. Okay, whereas you see here torque fluctuation is not going to happen. It is going to happen only at a higher air fuel ratio. And even you see the fuel consumption is also going to be lesser, even when the vehicle is running at freezing condition, where here they have taken the test considering the fuel consumption at 40 kilometers per hour, and the injection is going to happen during the compression stroke. So again, you're going to get 35% reduction here. So this 40% is the overall thing. So whereas this 35% only they have taken during the compression stroke. And with respect to the emission point of view, you see again you are going to get lesser emission for GTA when compared to the multi-point fuel injection. Uh, with respect to different air fuel ratio, this is the stoichiometric where you get right amount of air fuel mixture. So this is the emission with respect to NOx. I told you the carbon monoxide and hydrocarbon. So when you have the unburned fuel, it leads to carbon monoxide, hydrocarbon. So that is not going to happen in the case of the GTA engine, because you're going to have the proper uh, burned combustion thing you are going to get. Even in the case of multi-point fuel injection, compared to that of the traditional carburetor, you are going to get lesser carbon monoxide and hydrocarbon. Even nowadays, all this can be eliminated with the help of a three-way catalytic converter, which we have seen. And with the help of catalyst, the carbon monoxide gets converted to CO2, He converted to HCO, and NOx gets converted to nitrogen. But as per the emission norms, reducing the CO2 is also very important. And this CO2 will have the effect on the greenhouse and the atmosphere. So we can reduce CO2 only if we reduce CO into the system. So how we can reduce CO by different injection strategies, multiple injection strategies, and the proper amount of air fuel mixture, etc., for which the GDA is going to help. And even the MPF is also good, but comparatively it is less efficient. And now the recent researches are going on with respect to the vaporized fuel injection system. Maybe you can look into uh, that also. So it is going to be upcoming thing, maybe in another year or two. The vaporized fuel injection, because the companies like Bosch, they already started the technology. It's a vaporized fuel injection system. That's going to be the upcoming recent research which is going to happen, and that will still reduce the emission. Maybe when you go with Euro 7 or Euro 7 point, different category you have, they may come up with the vaporized fuel injection system. Again, apart from this volumetric efficiency, even the combustion efficiency is going to be higher for GDA. And even here, I'm going to compare volumetric efficiency and compression ratio. You're going to get higher volumetric efficiency, almost 5% increase is there, and again the compression ratio is also going to be higher, almost 1.5 compression ratio is going to be higher. So 10.5 we're going to get for MPFA, and 12 you are going to get for GDI. This is a very important graph. See the power and torque. This is where we need to see the performance of the engine. Obviously, we are more concerned on the power and the torque of the vehicle engine basically. You see here, you're going to get 10% improvement with respect to torque and 10% improvement with respect to the power. Okay, and again, the example what we have taken is a manual transmission vehicle with different parameters. Again, you're going to get the acceleration of the vehicle. When you check the acceleration, when you start the vehicle from 0 kilometer and when you're running the vehicle to 100 kilometer per hour, the time taken to reach 100 kilometer per hour, sorry, with respect to the time, okay, basically the starting time, basically the pickup time, okay, pickup time to reach 100 kilometer per hour from zero is less than 9.2 seconds in the case of GTA, whereas in the case of MPFA, it is higher than 10, close to 10.5 seconds, almost 10% reduction you can get in the GTA. So the conclusion here is I'm comparing the GDA and this multiplying, and we are eliminating the calculator because of the other issues what I highlight. When I compare these two, so it is going to run, the GDA is going to run frequently in stratified mode, where you are going to get the proper amount of air fuel mixers, and the advantage here is you are going to get even the reduction of CO2 production is also going to be reduced by 20%. One more advantage you are going to get, and you're going to get higher torque, almost 5 to 10% increment. So this 10% what I told is particular to this particular condition, to this condition. Okay, and it will vary with respect to different engine configuration, different port, different dia. Sometimes two cylinder, three cylinder is also possible. Even single cylinder is also possible. That's why they said in general it's 5 to 10%. Fulfills future emission requirements, but still the vaporized fuel injection is also the future one. Look into that one also. The 97% NOx reduction is achieved. And again, the percentage will vary again. This will also improve the brake fuel consumption. It will improve in the sense it's not going to increase. Okay, it is not going to increase. It's basically improve in the sense basically the BSFC of the engine is going to be lesser. It means the fuel consumption is going to be lesser. It means the mileage is going to be higher. Okay, you have to take improve now that manner. It's not that you're going to increase. When I say it is increase, it is basically you're going to reduce the mileage, but it's not going to happen such in the case of GDI. When I say improve, it is better with respect to the fuel consumption. Better in the sense the fuel consumption is not higher, okay? The fuel consumption is lesser, which means the mileage is better. You are going to get a smooth transition between the operation modes. You have different modes of the engine vehicle, which is running it different condition, lean mode, rich mode, stoichiometric mode, and again, the fuel consumption is going to reduce 15 to 20%. You're going to get higher power, spontaneous response behavior. So these are the things that we are going to get. So now we will see some of the videos. Okay, see, so here when I say the volumetric efficiency, the mass flow rate of the air, uh, basically the volumetric efficiency is basically related to the mass flow rate of the air getting into the system to that of the theoretical mass flow rate of the air. So here, as you are having the PDA system, I will show you one example. Here, what happens is you are going to inject directly into the combustion chamber. So where you have the throttle wall, throttle body, where it will flow the required quantity of air to the system. So here, what happens is the volumetric efficiency is going to be higher because the mass flow rate of the air which is entering into the system is going to be higher. Whereas in the case of the multi-point fuel injection system, or in the case of single point injection system, uh, what happens is this is the valve. This is the valve. What happens is it comes, the air fuel mixer comes into the combustion chamber through the wall, intake valve, uh, which means I told you the different means definition of volumetric efficiency of the engine. Mass flow rate of the air into the system, okay, to that of the theoretical mass flow rate of the air. The theoretical mass flow rate of the air is always 100%. It is not possible. So here, since the air and fuel gets mixed, there is the possibility is the amount of air getting into the system is going to be lesser. Plus, you have the throttle body, you have the throttle ball, again, that will control the amount of air and fuel gets into the system. And again, because of that less quantity of air coming to the system. Whereas in the case of GDA, you have only air, not air fuel, but you're going to inject directly the into the combustion chamber. But before it reaches the combustion chamber, you are going to get air and fuel mixer here. So this is the reason you're going to you're going to get more air into the system than the MPFA. That is the reason you're going to get higher volumetric efficiency. The fuel injection system injects the fuel at high pressure using an electronic fuel pump. And whereas you see the carburetor depends on the vacuum created in the engine during the suction stroke, and that is the reason that we cannot rely on the carburetor. And even the atomization is not better in the case of the carburetor. That's why we're going for a high pressure injection system. Basically, the multi-point fuel injection system or a gas direct injection will help for increasing the atomization, and also it will lower the emission, and it will also increase the power. So here again, based on the location of injector, I told you three type of things are there. One is single point, multi-point, and gasoline direct injection. So in the case of single point, what you have is it is similar to the carburetor setup, but atomization is somewhat better. And this is the location that you're going to locate the injector. This is the fuel. It is messaging. Okay. Okay. Uh, and this is the ECU. I told you you're going to get the control unit from the ECU. And this is the inlet valve. So again, this opens. So today even the question comes, why the volumetric efficiency is higher? Even that is the reason, because you get that injecting there, and to reduce the emission and also to increase the power output, we need to have the gasoline direct injection. So the air fuel mixture will happen in the combustion chamber. You see directly the fuel gets injected to the combustion chamber in the case of BDA. To improve the fuel efficiency, and even the emission going to be lesser, and the torque is going to be higher, power is going to be higher. Even I have seen some of the question coming from somebody like turbocharged gasoline direct injection. So yes, we can use it as a TGDA also, turbocharged gasoline direct injection part. Basically, you can also downsize the engine. So you're going to get almost 15 percentage reduction with respect to the CO2 by using the TGDA, what we call turbocharged, and also by the downsize the engine. We have seen the scavenging kind of thing, where this is you are going to expel the exhaust gas out by forcing the air into the system, and even that is also going to be. So it is having the fuel supply module, fuel tank, accumulator, distributor, injector. So based on the electronic control unit signal, it injects the fuel. based on the speed of the engine. Uh, so the fuel pressure gets varied with respect to the different speed, different RPM. This is how the you see how the compression is going to take place. You can see it. You see, this is the injector. This is the injector. This is the injector. You see directly it is getting injected. Okay, the gas of gas in direct injection. And again, the location of injector is also very important. Sometimes it can be located sideways, or it can be straight. Okay, even that also will have the influence over the power output of the engine. This is the air mass flow sensor. How much is the amount of air going to come in? So you can measure it with the help of air flow sensor. This is a throttle body. It will control what's the amount of air going to enter into the system. So it is also having the ignition coil which will generate the spark. There is a spark plug which will ignite. This is a GDA with turbocharging basically. So when you're going with this TGDA, your the displacement of the engine can be reduced. Uh, that is one advantage that because you can also go for a downsizing of the engine, and this will help for increasing the, the power output and also increase the fuel efficiency and reduce the uh, emissions. See, whatever when you're going with the turbocharger, the performance can be increased again. So the turbo lag can also be avoided. This is the air. This is the air coming into the system. It's basically the turbine turbocharger operating principle. Maybe you can also re-look into this video again so that you can understand TGDA in much more better manner. See, I told you based on the accelerated pedal, so based on the speed, when you increase the accelerator pedal, the speed gets increased. Accordingly, the fuel injection pressure also going to get increased, and the quantity of amount of fuel going to get injected to the system also gets varied. So, so this is the again you have the sensor. I told you different type of sensors when I'm explaining. So based on the accelerator pedal, the movement, you have accelerator pedal sensor that will give the sensing to the electronic control unit. Accordingly, the fuel injection quantity and the pressure is maintained into the system. It, these are sensors like you have NOx sensors, temperature sensors to measure what is the amount of NOx or temperature you have. Again, sensor you have. You have the controlled valve operations. You have the high pressure injector. It is a closed loop system basically, which I have also explained. Uh, is the lift actually the needed lift you have, and based on the activation time, the lift in micron, if it is terms of micron value, with the controlled valve open and without the controlled valve open. Uh, See, when the controlled valve is getting opened, you see the difference, and when the controlled valve is without opened, you can see that the lift is going to be higher. When the lift is going to be higher, uh, what happens is you inject more fuel depending upon the valve opening and the valve closing. And accordingly, the fuel gets spread based on the valve, the needed lift, basically a spring actuated thing. Basically, this is the electronic fuel injection system having the spring actuated system. Uh, Based on the different lifting movement, the spring gets um, the load accordingly, and accordingly you get the quantity of injection to the combustion chamber. So this is the vaporized fuel injection system. Uh, so it's almost a similar thing, but what you're going to have is you're going to inject the vapor. Basically, you get what is the advantage of going for this vaporized fuel injection system is that uh, it recovers whatever the loss of heat. Basically, you have different losses, right? You have heat loss, time loss. Out of that, heat loss is going to be higher. This system, vaporized fuel injection system, help to reduce the heat loss. Uh, when you reduce the heat loss percentage, what happens is you're going to have higher efficiency. Means you can increase the efficiency of the engine. It means the performance can be improved, and emissions can be reduced, and the output can also be get increased. And here, what we do in the case of EFS is vaporized fuel injection system is that it will inject a precise amount of 100% of vaporized fuel into the combustion chamber. Okay? So at a precise time and at a appropriately selected and optimum quantity with respect to the temperature, pressure to avoid. Here there is no pre-ignition fuel happening. So you are also going to avoid a detonation kind of thing, and you are not going to produce any NOx, and the combustion process is going to be complete with no unburned hydrocarbon left behind. Okay? So even in the case of GDI, also no hydrocarbon, but there will be this process is much more higher than what we have for TGDI. Here, the VFAS, you are going to increase the power output. You are going to reduce the pollution. Most importantly, the VFAS system, it replaces the waste heat energy. Basically, the heat loss, what you're going to get from the system. You're going to use that heat loss to vaporize the fuel. So how you are going to vaporize the fuel? Basically, you have different losses. Whatever the heat loss you have, you're going to use that heat loss to heat the system so that you get the vapor out of it. And you are going to use that uh, for VFA system to increase the power output and also to reduce the emission. So send you the snapshot of